方准备。
Hello everyone, we are the ubiquitous cosmos from KGHS and KSHS, and I'm Zorina. He is Robin. Our experiment focuses on observing the distribution of small droplets floating in a zero-gravity environment. In a zero-gravity environment, the motion of fluids behaves very different compared to that on Earth. For instance, the surface tensions dominate the shape of motion in liquids. Inspired by the 2022 experiment, the water vortex, we extended research to explore how gravity, friction, centrifugal force, and surface tension influence the motion and distribution of small droplets under the different rotational speed. And here's the theories we applied. First, we studied the circular motion of droplets in a container to observe the force acting on the liquid and its motion trajectory. Then, using the Young-Laplace equation, we learned that the surface tension between the droplets and the plane affects the contact angle between them. Then this is our experimental setup. On the Earth, we use the finger spinner and fix the device on the top of it to perform the rotation. Then in space, the device will be attached to a gyroscope of observation. Next, I'll explain our experimental process. First, we add a few drops of water to the container. This step helps determine the initial distribution of the liquid in a container. Next, we slowly rotate the container. At low rotation speeds, the distributions of the liquid is mainly influenced by the gravity and surface tension. We can observe the initial movement of the water droplets. Then, the rotation speed is increased. As the speed increases, the water is pushed toward the outer surface of the container, forming the space-perfect distribution pattern. Finally, the rotation is stopped and the final distribution of the water is observed.
Right, and this is a phenomenon on Earth. I use a simple diagram to say what it will be. And this is my free body diagram, and it shows that before rotating, the droplet will influenced by the gravity and the surface tension and forming a flattening shape. And during the slow rotation, and we can the friction prevents the noticeable movement, and so the upper part we can see the video. The droplet's upper part at the low speed will shoot upwards, and it will drag outward by the centrifugal force and clustering at the edge and forming a thin layer on the side wall like this. It will gather in at the edge, and this is the hypothesis in space. And under zero gravity, the water droplets start as a sphere and are affected by gravity without friction, and without no force, there's no friction, so the droplets stay stationary until contracting by the container wall, and rotation increase and the centrifugal force and moves the jumping outward at low speed. It behaves like an Earth remaining stationary. Thanks for everyone.